So I decided to make another modification on this machine, and let me show you what it is. It is opened from the back, and there is the back cover there. When I first got on of these machines, I noticed that here and here there are speaker outputs. I also noticed that there is a button here that is called speakers off. But if I plug the external speakers on these two outputs, there would be no sound. What I found out is that this machine has some versions that had internal audio amplifier, and with this amplifier they would make use of these two plugs here, and also on the button on the front which has speakers off. This is the power supply board, and there are two slots here, this slot and these slots, these two slots. So these two slots are used for that internal audio amplifier if the machine is on the version that has them. So I thought that everything is ready on this machine to use these two slots here in case somebody wanted to put an audio amplifier here. I searched online on eBay to find specific boards that would fit on these two slots. So they should be made on purpose for this machine, and that would cost me more than 120 euros for a pair. I saw the schematic on the service manual, and I thought that the components are not that expensive, and that normally this should not cost that much. But anyway, somebody bothered to make a PCB that would fit here. So, I mean, it's a free market, he can sell it as much as he wants. What I thought is that if these cards would fit in there, why don't I make my own card? And I started thinking about this solution. The first thought was to try and copy the original amplifier of this machine. The components are not that much, and the schematic is not very complicated. And on the service manual, the full schematic of the two amplifiers is there. Somebody can find it and copy it and make his own amplifiers. But I found this to be a challenging task, and I thought of another solution for this. And let me show you what it is. So, as you can imagine, I made my own amplifier card that would fit into the original slot of the Revox. Let me show you how I made this. Here, can you see here? Okay. These are the contacts. To make this, I used this conductive adhesive tape, which is a very good product, and I didn't know that, I realized that solder can stick on this. So I cut small pieces of this tape and stuck them here after I measured exactly where the position of each contact should be, as you see in the picture. It was challenging a little bit at the beginning to be able to solder on this tape, because the heat would make the adhesive go away and it would unstick from this card, from the PCB. But after some efforts I finally did it. Let me show you the components that I have here. So this is the power in from the amplifier of the Revox. This is 33 volts AC. First, it passes through this fuse, and then it passes through these two plugs here. These two. These plugs go to a button at the top of the Revox, because I thought that maybe when I record, the working of this amplifier would ruin my recordings. So I thought I should be able to stop the power from the amplifier if I wanted and put power to it whenever I want. So I made a button. You will see it on the Revox later. After these two plugs, the power goes through this full bridge rectifier. It goes through this capacitor, which is 1000 microfarads, 63 volts, and then with this cable it goes to this switching power supply. This power supply is a very cheap one, I think 1, 2 euros, 3, something like that, and takes as input DC voltage up to, I think, more than 100 volts, and on the output it gives 12 volts. This is switching power supply. Because of this I was afraid that if the whole board is working while I'm recording something, it would ruin my recordings because of noise. That's why I made this with a switch to turn on and off. Okay, the output of this 12 volts would go to this amplifier here, which is a very simple class D amplifier. It's also very cheap. It's a PAM something. You can see the picture of the listing now. Okay, and this amplifier here would take the 12 volts coming out of this power supply and it would work. So let me show you the other cables. This is the speaker out of one channel that comes here, because there is the speaker output of one channel. This is the speaker output of the other channel, and for the other channel I made another small PCB just to get the inputs and outputs from the other slot. This is the only job for this PCB. At the same time, there is a line in from this and a line in from this that goes here, which is the line in of this amplifier. I used it like that, so I would fit at the beginning the line out of the machine directly to the amplifier, and I would get too much noise. I will show you that noise. Now I will put a video of my first efforts when I plugged on the slot this amplifier, where you can hear the noise that I would get. So this is how that thing looks like. This is the main board. see? If I have the volume down to 0, I get this noise. If I lift the volume to 1 or 2, okay, the voice goes away. The noise is only on 0, but just a little bit and the noise goes away. Anyway, I will put some free music now. Okay, we are back here. So I tried several things. At first I thought that the problem was the power supply that was not stable. Mostly I thought that this power supply, it's a switching power supply, and it needs some minimum load to work correctly. So first I tried to put various capacitors to the output of the power supply with various capacitances, and the noise would not go away. Then I tried some dummy loads on the output of the power supply. The noise would not go away also. Then I thought that I should eliminate the power supply factor, so I used a 12-volt battery to power this amplifier, and the noise was still there. So I realized the power supply was not the problem, but the problem was the line input. So what I did, I made here, you see these two potentiometers? I think these are 100K. Yes, right, these are 100K. So I made a voltage divider on the line in, and that would give some resistance to the line input. And also I could, like that, calibrate the two outputs to be of the same level, but this would solve my problem. I didn't need the full voltage of the line in, because putting the volume of the machine not very high, I would get distortion. So I realized that I didn't need the full voltage, so putting these things would also let me calibrate the output of the Revox, the input of the amplifier, at a level that I thought it would be nice to have it. Okay, this is the back side. Too many cables, I know. I didn't care about making it look nice. I only cared about make it function correctly. So what I will do now, I will use this tape here, and I will keep some of the cables down so that this doesn't take too much volume. What I realized after I tried to test this is that this part here, this spot here, would be very close to another contact in the machine. It wouldn't make contact, but it was dangerously close as I saw it, so I will put this tape also here to protect this also. I'm gonna do this now. I will put this tape here, make this more nice with all these cables, and I will come back. Okay, this is how I finally made it. This is an indication of all the pinout of that card. So the first two is 33 volts AC, then is ground, then is speaker out minus, speaker out plus, the next two do nothing. I could maybe not put adhesive contact tape there, but I found out later that it did nothing. Anyway, no problem. And the first one up here is the line in plus. Okay, the same applies to the other board here for the other slot, but you only need these four. That's why this one here has only four contacts. Okay, this is the PCB. Let me show you. I think like that is pretty okay. And here you can see here, okay, the machine has something that inserts here, so I had to use a Dremel and make a cut here on the PCB so that this thing can be able to fit in the slot. Okay, this is the last thing I wanted to say about this PCB. Okay, now I will put it on the machine, I mean in the machine, and I will test it in front of you and show you how it works. Okay, now I will show you how the amplifier fits into the machine. First, you see, this is the slot here, and there is a small plastic piece here, so this slots right in, just like that. And then I have to fit the other channel there. This I should be careful so that the pins are aligned with the outputs of the slot, because there is no way to have it automatically aligned. Let me see. Yes, they are aligned. Okay, let me show you what this is coming from a switch that I put up here. You see this switch? I had to put it as much down as possible so that the plastic cover would be able to slide above it. That's why this is so down. Look at it from there. Okay, and these two must go to the plugs, to the two plugs that I made for them there. I will stop the video because I cannot hold the camera and do it at the same time, and I will continue right after. There it is, fitted totally. Back there, I don't know if you can see it, it's the spot where this would be very close to that contact there, but I put this tape and it's okay. As you can see here, there is a switch that goes into these two plugs in there, and this job is to turn on and off the power that goes to the amplifier. The amplifier is not heavy at all, so it doesn't need any more support. It can stay like that and it's okay. And from there I can make the calibration to this two voltage dividers, these potentiometers that act as voltage dividers for the line in. and adjust the line in. Now I will put some audio to the line in, which is there, to the line in of the machine, and put speakers to the outputs. I will use some Google free music, and I will show you how this works. So I will put some free YouTube music there on the cell phone. I will put it on the line in here, and from the speaker out there, I have these two speakers there that will play the music. Okay, let me show you something. When I put this to 0, do you hear the noise? When I lift it just only a bit, look, the noise goes away. Okay, that's why I used these voltage dividers there, and let me show you. I will just slightly give some input resistance. Okay, this stopped one channel, let me do the other two. You see? The sound stopped completely. So, now I will turn on the music. This is the line in, listen, okay, here too. You see? It's pretty loud. And look at that. Stopped. You see? This stops the power to the amplifier. Okay, this is the modification. I will close the back cover now and show you the final result with the cover closed. That is the final result. Okay, I didn't pay attention too much, and I did more damage here than that was necessary. But anyway, the result is that now I have an internal amplifier and can use it with the speakers here, speaker outputs. I have this to turn on and off the amplifier whenever I want. And this is how the machine looks like now. Okay, that was all about this modification. Bye bye.